All right, welcome back, folks. This is a warm-up preparing for the test on the parallel and intersecting lines. We're beginning with relationships of angles here. If two angles are vertical, this should prompt you to do like a call and response. Every time I say this, this should be really familiar to you. If two angles are vertical, then they are congruent. Good. If vertical, then congruent. That's the vertical angles theorem, that we proved last class. Secondly, if two angles are a linear pair of angles, then they are good, supplementary, another one that should roll right off your tongue. If not, put these on a flashcard and memorize those. This next one is a little bit more logic rather than straight memorization. If two angles are both equal in measure and blank, then each angle measures 90 degrees. Supplementary, good. It's like we're saying, if they're the same, both x, and we add them together to make something so that they're each 90 plus 90, they would have to equal 180, which means they're supplementary. Okay. Next part gives us this graphic, and we're trying to find the measures of angles that are shown. For all these, what you need to do is see the relationship that these angles make with others. And this is so central to this unit. When I look at A and I see that 28 is right next to it like this, I need to know what this relationship is between these angles. It's a named pair relationship. What do I call them? Linear pair. And then I say, okay, if that's true, if they're a linear pair, then what? If linear pair, then supplementary. So I know A and 28 are supplementary. So I'd come up here and say 180 minus 28 equals 152. Then I'd look at B. What's the relationship between B and something around it? Good. B is vertical angles with 28. If vertical, then congruent. So B is also 28. And I can write them in here just to help myself. What about C? What's the relationship of something near C? Good. C and B. What's their relationship? Same side interior. Well, that's only helpful for me if the lines are parallel. What do these marks mean? Parallel. So if parallel cut by a transversal form same side interior angles, then those angles are? Good. If parallel, transversal, same side interior, then supplementary. So I know that I'm going to take the supplement of 28. Well, that's the same as A. Could I have used A? Because A and C have what relationship? Corresponding, which would be congruent. So 152 for C. Now, D, if these marks are the same as these marks, what does that tell us? They're equal. So if that's D, this is D, which means this whole angle is how big? If that's 1D and this is a second D, 2D. 2 times D, right? Now, this angle 2D and this angle A are in what relationship? Corresponding. And I need to know that these lines are parallel, are they? They are. So if parallel, transversal, corresponding, what's true about these two? They're congruent. So 2D equals 152. So D is equal to 76. E. What do I see with E and other angles around it? Excellent. It's a linear pair with this symbol. This symbol means 9 degrees right angle. So if it's a linear pair, they add up to 180. 180 minus 90 is 90. E is also a right angle. F. What do you see around F? Linear pair. That means F would be 180 minus 62 is equal to 118. G. What relationship does G have with things around it? Vertical with 62. If they're vertical, then they're congruent. So that's also 62. H asterisks. Now, there's a couple ways to find H. What's the relationship between H and 62 here? What is it? Let's first identify the transversal. Do you guys agree that this is the transversal? And it's touching both of them. So that means these are the lines we're talking about. If you copy and paste, these fall right on top of each other. What are these called? Corresponding. And if parallel lines, yes, transversal and corresponding, then congruent or supplementary? Congruent. So these are both 62. That's the answer. But maybe you didn't see that. In which case, what does this mark here mean with this mark here? Equal. So this is H in there as well. What do you know about all three angles in a triangle? They add up to 180. I reminded you that down here with this little asterisk. The triangle angle sum theorem says they add up to 180. You can use that in the problem above, but we haven't proven it yet. So that's what we're doing next. Regardless, if you did this 90 plus 28 plus something equals 180, this would end up again to be 62. And J, what's the relationship between J and those things around it? It's 152 with C. We're not going to say it's anything with D because there's no transversal connecting them, right? But with C, they're vertical angles. If vertical, then congruent. So if C is 152, J is 152 as well. How was that for you? 5, I did that really well. I got all the answers. 3, I missed a couple, but as you went through it, they make sense. I'd get them next time. 1, there were some things that are really confusing to me. What is this vertical angle you speak of? Okay, good. 3's and up. All right. Next piece. In order for us to use the triangle angle sum theorem, we have to first prove it. So let's prove this one. I'm going to fold this paper back so that we have a lot of nice space to prove this thing. How do I start? Given M and N are parallel. Given. Now that'll be important, but doesn't really take me there yet. What can I do to get me there? Well, what I suggested was that you consider how we did the linear pair theorem. And you'll remember with the linear pair theorem, I have one nearby. What we said is that if linear pair theorem, we said if 1 and 2 are a linear pair given, we could say that angle 1 plus angle 2 makes angle XYZ, angle addition postulate. And XYZ is a straight angle. It equals 180. Therefore, measure of 1 plus measure of 2 adds up to 180. That was the broad strokes of this. Let's do the same thing here. What do you know about 4, 2, and 5? Measure of angle 4 plus measure of angle 2 plus measure of angle 5 equals measure of angle ABC. We don't know that they're supplementary. We don't know that they add up to 180 yet. We do know that they make ABC. What reason can I give to say that we know that's true? Good. Angle addition postulate. And ABC is what kind of angle? Good. ABC is a straight angle. What's our reason for that? Good. It's in the picture. We can read it as a straight angle because that's the one thing we get in geometry as a, you can assume it, is if a line appears straight, it is straight. Could you have called that the definition of a straight angle? You could, but that means you can't use it for what I want to use it for now. What does a straight angle mean? Close. 180, right? Supplementary is a word we use to describe multiple angles adding together to 180. A single angle, I mean, could you say it's a single angle supplementary? I don't think so. I think it has to add together to make 180. So the measure of ABC equals 180. Why? Because that's what a straight angle means. If you had used definition of straight angle here, saying that that's what I call a straight angle, is something that looks like this, then you could say, if it's a straight angle, then it equals 180, right? If-then statements are always usable, as long as they're true. Now, What do you notice about these two yellow things? They're the same thing. So what can I say? Good. What do I call that? Excellent. Substitution property of equality. Could I have called this transitive? It's set up for transitive, so I could call it transitive, but why bother? In the world of equality, we can always say substitution, so let's do that. All right. So I got somewhere. I got some stuff here. Where am I trying to get to? I didn't actually do what I should have done. How do we always start proofs? Shouldn't I write where we're headed as well? And if I want to get here, have I achieved anything that's kind of close? I mean, I've got an equation equaling 180. And I got the 2 where it needs to be. So all I need to do is really look at 4 and 1 and see how they can swap out. Ella, what you got? They are. Angle 4 and angle 1 are AIA, right? They're making this a transversal relative to those two parallel lines that we've got. They're AIA. What else is AIA? Good. Angle 3 and angle 5. I'm going to also call those AIA because I want to save a little effort. I'm going to call this definition of AIA. I'm doing both of those steps in one because it's the same step. Autumn? Yes.
And then
This doesn't require any of this stuff.
yeah. So like if I put that first and then did the other stuff, that also makes sense.
Yes, it would.
So like this isn't the correct one. This exact way.
No,
Okay.
the sequence doesn't matter. Like if you're baking a cake, does it matter if you put in the egg first or the flour first? Not so much. Does it matter that you put in the flour and egg before you heat it up? Yeah, like there's some things that matter in sequence, but not everything. Okay, so we said that these are alternate interior angles. What was the point of that? Because what's next? If AIA, then what? Is that true? If AIA, then congruent? I don't know TBH either. Are these AIA? Are they congruent? I can call them AIA without them being congruent. But if I want them to be congruent, I have to have 3 things, right? Parallel, transversal, and AIA. Except we got AIA. Parallel, transversal, AIA. Those 3. We proved this, right? This was one of our proofs that you have to have on the test. Parallel, transversal, AIA. If those all 3 exist, then we can say congruent. I'm not a stickler for the transversal. That's me being actually I am a stickler. That's me being a little bit officious to ask you to do that. There's a reason I want you to think about 3 things necessary to prove congruence. You'll see that later. But parallel must be there. We've got parallel. Then we said they're AIA. That means they're congruent. Angle 4 is congruent to angle 1, and angle 5 is congruent to angle 3, because both of those are the same reason. Parallel, AIA, transversal, then congruent. All right, we're looking good. We wanted to swap out 4 with 1. Now we've got 4 and 1 are congruent. So can I do that swap now? Yeah. What would I call it? But this isn't substitution what?
No, substitution property of congruence.
That's what I was about to say.
Okay. We're struggling a little bit here, aren't we? Because this is congruence. And so you want to say substitution property of congruence, but does that exist? It doesn't. Could we do transitive property of congruence with this? Because that's not congruence. So we got a little work to do here. Yes, measure of angle 4 equals measure of angle 1, and measure of angle 5 equals measure of angle 3. Why is that true?
You make it valid.
Definition of congruent angles. We said they're congruent angles. What does that mean? That means that they have the same measure. Now I've got 4 is congruent to 1. So I can swap this 4 out with this 1. I've got 5 is equal, measure 4 is equal to measure of 1. Measure of 5 is equal to measure of 3. Swap those out. What's my reasoning to swap those out?
Substitution.
Substitution. Substitution what?
Yeah.
I don't see congruence here.
Well,
Property of equality. And because I'm finished, drop the mic, QED.
you always have to keep
Only if you're cool.